Hey YouTube, it's JP Dillon. This is the bottom half of a 1959 Philco Predicta Princess. And this is the top half, which just got swapped a brand new 17D RP4, which the owner of this set, who is a viewer of the channel, was savvy and resourceful enough to get this brand spanking new picture tube, because the old one had an open filament and was utterly useless. And I didn't think to do any sort of video on swapping the CRT, because there's plenty of that info out there. There's a couple of videos I saw, but most notably, if you guys are into Predictas, check out B. Anderson TV. That's the letter B, Anderson TV, all one word. That's Bob Anderson. He is one of the predictive brains of this community of people. And he has the skills and knowledge to fix just about anything that goes wrong with one of these. I only have maybe about a half a dozen of these under my belt, so they don't really come around much. I don't see them very often, and they're not very fun to work on, but I am willing to tackle this one and see what it needs to get going. So what we're going to do is take a brief assessment and see what it's going to need to get going. And let's start by taking the back off and taking a look inside. And when you take the back off of one of these, this is really what you're greeted with, is a very cramped chassis. And this one has signs that it's been serviced over its lifetime. It's a very high hour set. And I guess maybe he bought it from the original owner and they just kept on using it until they couldn't use it anymore. But the board, like many of these, is definitely baked. You see an orange drop down in there. Filter looked loose, but it wasn't. It is missing the high voltage rectifier there, which is either a 1K3 or a 1B3. Trying to see what that is. It's a 1G3. I think I have a 1K3 and a 1B3 on hand. I don't think the pinouts are different. I think it's just a voltage and current rating. But it is a transformer set. I'll have to find out whether he wants the tuner serviced and aligned, or whether he just wants to have a direct audio-video input, which many people like. Although without a preamp on some of these, direct injection of composite video usually doesn't yield enough signal. But we'll get into more of that later. So right now, it looks like, if we go back in here, one of the tuner tubes is missing. So we need to get that. But that won't stop it from getting a raster. That will. So we need to get a high voltage rectifier in there, and I need to see what I have on hand and what the comparison is with a 1G3. And then I think we'll just soft start it with a dim bulb tester and see if it even comes up at all without the CRT attached. And then we'll go from there. So I do have a 1K3 and a 1J3, and you can definitely see the size difference. So there's probably some difference in current handling, but we're going to look up the differences. Okay, so here's the 1G3, which is good for 21,000 volts at a maximum of 1.1 milliamperes. And let's take a look at our 1K3. Let's see here. That's a 22,000 volt versus 21,000 volts. So it's a little beefier, but less current. It's only half a milliampere, whereas that one's 1.1 milliamperes. And then 1J3 looks like 22,000 volts, and again 0.5 volts or 0.5 milliamperes of DC current. So the 1J3 and the 1K3 aren't going to work for this application. Let's take a look at the 1B3. And the 1B3 again is a 22 kilovolt half a milliampere with 50 milliamperes peak. That's 35 milliamperes peak. Actually, they say 50 as a flyback rectifier. We need to read these again. Reading's fundamental, kids. Yeah, so the 1K3 is like 50 milliamperes peak. DC output current 0.5. So these really, the ones that I have really aren't gonna work. I mean, they might work, but they also might load down the flyback, which is not a good thing. So I really need to get my hands on a 1G3 to be able to pursue this realistically. Of course, they say the 1B3 and the 1G3 are the same and can be subbed for each other. So that's, that's promising. I can always stuff a 1B3 in there, I guess. I have those. All right, well, I guess we'll do that. Okay, so I have a temporary high voltage rectifier in there, although we're not going to start the sweep yet. I've got the horizontal disconnected. We're just going to fire it up with a dim bulb tester and see how things react and reform. All right, I've got my cheater cord hooked up, so let's go ahead and push the magic button here. That's pretty bright. Let's see if it calms down a little bit. Looks like it's starting to. Yeah, we're just going to give it a little bit. Let the filaments warm up. And see if the light gets any brighter. But so far, it's actually pretty dim, which is good. But it could also mean that we have no B+. So I think what I'm going to do is just take some quick measurements. So a good check for a presence of B+ is to go up to the horizontal output cap and measure from there. And as you can see, we got half a volt there. So pretty much like I thought, there's no B voltage running. We're entirely on filaments, and that's why we're not drawing a whole lot of current. So there's a number of reasons for that. We could have an open fusible resistor. We could have a bad transformer, a bad rectifier. I mean, it's highly unlikely that we have a bad transformer or rectifier. It's usually when that happens, they don't work much at all, or they draw way too much current. But if we come up here, we see that we don't have very much in the way of B+. We've got a whopping about a volt, which isn't very much. So I think it's time to pull the chassis out and take a closer look. Because back in there, behind the transformer, looks like a very badly burned dropping resistor for the B. I think that's a surge resistor, and it is responsible for delivering B+, so we need to get this thing out of here. Yeah, typically after you remove the knobs, it's just a matter of unmounting all the chassis screws, taking down the picture controls, and then of course there's the power switch and the speaker, which are up in there. So I'm going to go ahead and yank this guy out. So here is what a predicted Princess chassis looks like removed. And the tuner and the main chassis do separate via plugs to make it easier. But I will likely be servicing this, so it was easier to remove it separately. And you can see the chassis here is just utterly filthy. I had to remove this tube to get in far enough to disconnect the speaker. But wow, just wow, this is pretty filthy. And here's that plug-in surge resistor. Crusty, corroding in that socket. I'm pretty much betting that that's defective. This doubler here could be shorted too, which would have taken that out, because this definitely looks like it got a little toasty, but we'll ohm that out in a little bit. But this is just an overview of God, how crusty this is. This is really bad. I'm sure people have seen worse, but wow. And then on the bottom side, this board will have to come out to service this thing. But you can see all the little solder cracks and oxidized solder, and tubes and circuit boards just don't mix. And it's very rare to find a set with a circuit board that doesn't have oxidized socket pins or cracks in the solder. There's another fellow TV collector, he knows who he is. I think he said these things are like tin foil on a graham cracker. So that's the whole chassis. And let me move this out of the way so I don't murder it. Don't want to break those connectors. But yeah, there's the IF board. And then these little evil gizmachis, these are couplets. There's, I believe, 3 of them in the machine here. This one may have been replaced already, or it may not have been. I don't know what. This looks like a Sprague part, so it's definitely not original. But we need to build new couplets for these too. These are such an undertaking. If you're getting into vintage TVs, a Predicta is not where to start. So, but what I do want to do is test this guy. Given the fact that he's got crusty leads, that could be why we're not getting a B voltage connection, because you can see that these are kind of all funky and messed up. But that does deliver your B voltage from the rectifiers there at the left to the rest of the thing. Let's just do some quick checks and make sure the damper, or excuse me, the doubler is not shorted. And just a quick test here. Not shorted. Let's clamp onto this guy and see if he's still alive. $390K? Yeah, I'm thinking not. I think that was just measuring the resistance through me. I'm pretty sure that ain't supposed to be no 390K. That's supposed to be 7.5 ohms, so that's why we have no B voltage. So I can put something in there of close enough value, like a 10 ohm at 25 watt or something, just so we can power the thing up and see how it behaves. In fact, I got something even better. We can just use one of my load resistors, which is 8 ohms at 300 watts, so not worried about that. Okay, so we have our giant resistor in series. I'm just going to turn this on. And let's just see out of curiosity here. If I take this away, yep, there's definitely a noticeable current draw difference when I apply and remove the resistor. So that's good. Now with the tuner not hooked up, we're not going to hear or see anything. Obviously not with a picture tube missing. That bulb is getting considerably brighter though. Let's take some measurements here. Let's do our B voltage test here again. So now we have 150 volts, which is about right considering it's being vastly limited. And so if we apply the horizontal top cap here, doing that briefly, obviously we're not at the right frequency. But that tells us that the sweep circuits are trying to work. And just taking some brief measurements here right on the doubler. There's our 150 volts we saw at the socket. And the bulb's starting to get dim again, so things are reforming, which is really good. That filter can's still cold. That one's still cold. I'm just going to let this one cook a little bit longer and see if there's any significant changes in operation during that time. I'm not going to run it up on full voltage yet. When we get to that point, I may plug in the CRT just to see if it lights up and to see if we get some kind of a raster. Because I really want to know whether the flyback in this thing is good to go or whether it has, has to be replaced. Because he said he was willing, the owner of this was willing to get another flyback, and he said he had access to one, so that was kind of cool. But definitely need the fusible resistor because we're just operating off our giant test resistors right now, which is close enough to allow us to see it run. Like that big cracked black beauty there. But basically, in order to service one of these, that board has to come out, and that requires lots of unwiring, marking things, taking the board out, cleaning it off. So this is just, yeah, these aren't fun. These are money, and money that you have to earn for sure. So let's let it cook a little bit more and we'll come back to it. Alright, so where we're at right now, it's been running for about an hour and nothing's gotten hot. So I'm just going to, I have the picture tube hooked up. I don't have the tuner hooked up. We're going to juice it and we're going to see if anything happens, if we get light or anything like that on the screen, or if it blows up horribly and we're all doomed. I really don't know. So the meter you see is monitoring B current. And we're just going to flip the switch, see what happens. So far I got no measurable current. That doesn't seem right, does it? Oh, we had something. Little tiny picture there on the screen when I cycle the power. Alright, so I need to figure out why we don't have any current draw. Because it seems like we should be getting something here. Maybe the meter's just not registering anything. Or we could be on the wrong setting here. Maybe that's measuring the pre-rectifier side. Let's try this again. There we go. 1/4 of an amp. Almost an amp. We get any light on the screen? Oh, there we go. We got a vertical line. No vertical deflection, but we do have high voltage. So that's a good thing. We at least have high voltage. Alright. So that's good. That tells us that at least the high voltage system is alive. We have no vertical deflection, which could mean anything from a bad transformer to open yoke winding to a bad tube to bad circuit, couplet, etc. A lot of troubleshooting ahead, but this at least gives us an idea as to what we're up against, which is going to be very difficult, but to see the vertical line on there was pleasing because that tells me that the flyback is alive and it's working. So this will conclude the analysis portion of this repair, and this will be a long, tedious journey that will probably have multiple parts spanned out, because I don't anticipate being able to bang this out over the holidays. So I hope you guys enjoyed this segment of it. In the next segment, we'll see if we can do a little troubleshooting on the vertical and maybe get that alive so that we can at least see that we have a raster. And then once we can gauge the health of the vertical system and maybe get it to work, then we'll focus on doing the chassis cleanup and tear down and the restoration process. So anyways, thanks for watching the video, guys, and more stuff to come.